Hey, math tutor here. These are step-by-step solutions. I'm going to explain exactly how to write your answers. So we're supposed to find g of 3. So that means plug 3 into x. So I wrote 3 there. And then we need to find the value of the series. It's geometric. Well, that's nice. That's one of the few types of series we can actually find the value of because we have a formula for it. So r, that's called a common ratio, right? And that's always that number that's like the base of the exponential. And then we have a. So a is like the first term of the series. So what you can do is write out like the series. So the first term is actually kind of the 0th term, because it starts at n equals 0. So replace n with 0. And then actually you don't have to write out any more terms because this is the only term we care about. This term equals 2. It's just 2. So if you notice, there was already a hint that it was going to be 2 right there. So this is something you can put to memory, I guess. If you have a geometric series and it starts at n equals 0, then the first term of the series, or 0th term of the series, I guess, is literally just that. It's like the coefficient of the geometric series. Cool. So, all right. Now, you put that a value there, because it's a over 1 minus r. The r value goes there. You could simplify it, 5 over 4. But remember, you don't have to simplify it. No simplifying answers on the FRQs. This is how I would actually write my answer on the exam. Cool, on to part B. So now we're going to do a derivative. So the derivative of 2 is 0. Derivative of negative 2 fifths is negative 2 fifths x is negative 2 fifths, right? And then, it's like power rule, right? Cool. So that's your answer. And the way I would write it is exactly the same. Cool. Part C. We have to do whatever this is. There's a lot going on here. So I'm going to explain each and every part. So they're talking about f. So f is like the previous part function here, the derivative. And they want the second degree, or they're talking about at least, the second degree Taylor polynomial. So this is a polynomial, but is it second degree? Degree means the largest exponent. Okay, so they only want us to go up to here, right? Like they want the largest exponent to be 2. Okay, so they use this to approximate f of 5 halves. So literally they took like 5 halves and they plugged it into x, okay? And if you do that, you will get, if you literally do that math, you will get negative 3/10. So they did that for you, which is interesting. And by the way, it is in fact an approximation because, like in theory, this is an infinite series, right? Like, so you would have to plug 5 halves into all infinite terms to get like the actual answer in theory. So because they only plugged it into 3 of the terms, they just get like an approximation. Okay, well, so they did that for us. So what are we actually supposed to do? They want us to get the error. So whenever you see these absolute value bars and the stuff in between it like that, that is error, right? So I wouldn't worry about like how to calculate this exactly. They did an approximation of it over here, but I wouldn't worry about that. I wouldn't worry about that. Don't worry about the stuff inside the absolute value bars exactly, that specific stuff. Just know that this means error, okay? And so we're supposed to show that the error is less than or equal to 1/5. Okay, so there's 2 types of errors in AP Calculus. There is alternating series error bound specifically. And then there's like this Lagrange error bound as well. In this case, we're going to use the alternating series one. Why? Because this is an alternating series, right? You have terms that are alternating in sign. Cool. All right, so the first step with alternating series error bound in FRQs is to write this sentence. There have been some recent years, where they really want students to write this sentence. Like if you don't write this, you're not going to get full credit. So I would always write this sentence for any FRQ, part that's like similar to this. Just err on the side of caution, write this sentence. Now, okay, the idea of alternating series error bound is get the next term, the next unused term. Oh, so we're going to use this term now, right? That's why there's one term left over, right? We're going to use this for the error. So 5/2 is the number that we're using for x, right, in this problem. So plug 5/2 into x. There you go. That's your error. And to be clear, it actually isn't necessarily the error. The error is less than or equal to it. So that's why this is called error bound. It doesn't calculate the error. It calculates an upper bound for the error. Like we know that the error can't be bigger than this. Right. Okay, and then we're supposed to show specifically that the error is less than 1/5, less than or equal to 1/5. So is this less than or equal to 1/5? I guess. I mean, you could do the arithmetic here if you wanted to. It's a little bit annoying to do this without a calculator, but you could go through and do this. Actually, it looks like this would be equal exactly to 1/5. So this is true, right? But you don't have to like actually write out the arithmetic or show this on your FRQ, right? Because the CollegeBoard doesn't really care that much about arithmetic. So you could just write it like this. This is how I would write it on the exam, and you will get full credit. Okay, and then on to part D. So part D, we're supposed to write e to the x, the first three terms of e to the x in the series. So e to the x follows this pattern where it's like x to the n over m factorial. So this is like n equals 0, this is n equals 1, n equals 2. You can simplify it a little bit if you want to, but you don't have to simplify on the exams. This is how I wrote my answer. I guess I kind of did simplify it in my head. Okay, and then for part 2, we are doing it for h, first three terms of h. H was this thing, 25 times g of x. Okay, so g of x, we need the first three terms of that. Okay. So plug that in for g of x, first three terms. And then we need the first three terms of minus 2 times e to the x. First three terms of e to the x, which we wrote here. Cool, so plug that into e to the x. There you go. That is your answer. You don't have to like distribute the 25 and 2 and combine like terms. No simplifying on this exam. All right, well, the official solutions are not out yet because I'm recording this literally the day after they released just the FRQs. But as soon as the official solutions are out, I'll post a link to those in the description so you can compare my solutions to the official ones. All right, that's it. Thanks for watching.